On September 1st, 1859, Richard Hodson and Richard Carrington both noticed something strange was going on. Telegraph stations spontaneously caught on fire, and all over the world, colorful auroras could be seen across the night sky. The world was so bright that some people got up for work at 1 in the morning. For a couple of days, people began to wonder, is this the end of the world? And then, just as suddenly as it began, it ended, and everything went back to normal. If you've never heard about this, you're not alone. It's not an event frequently brought up in history class, but nevertheless, this event changed our understanding of the world we live in. It was named the Carrington event after Richard Carrington, one of the first people to observe this phenomenon and connect it to concepts we already knew about. We now know the Carrington event to be the largest geomagnetic storm in recorded history. The Carrington event occurred because of a massive coronal mass ejection, or CME. Richard Carrington had an interest in sunspots and found a correlation between these noticeable places on the surface of the sun and the likelihood of the sun releasing a CME. When the sun releases a CME, it's like a blob of plasma, but it has so much energy around it that the kinetic energy generates a magnetic field around it. The Earth also generates a magnetic field through the kinetic energy generated by the movement of the liquid outer core. When CMEs come near the Earth, they dissolve upon contact with the atmosphere, but push the Earth's magnetic field. The magnetic field is what influences the movement of particles, and with all this energy coming closer to the surface of the Earth, electrical charges are often concentrated in those areas. In 1859, the telegraph booths were overwhelmed by all the electrical energy pulsing through their wires all at once and released some of that, which caused fires. It's estimated that half the telegraph booths in the United States were affected by the Carrington event. Now, all this history is interesting for sure, but it also begs the question, what would happen if a Carrington-sized geomagnetic storm occurred today? The answer is a bit complicated. In 1859, the world was a very different place. Electricity was not nearly as common in everyday life, meaning that the damage was minimal. But today, we live in a world where electricity powers our lives. There are very few aspects of modern life that a Carrington-sized storm would not have the potential to affect. Not only would the magnetic changes cause power outages, it would be impossible to repair the power grids again without manually putting the pieces back together. If large parts of the world were shut down without access to technology, we could be looking at years of powerlessness in some places. Battery-powered technology would also be dysfunctional for the time the magnetic field is affected. Batteries depend on particles being able to flow throughout, and under a magnetic field, the natural flow is disrupted, rendering batteries useless. That means that radios, car batteries, and flashlights would all be out. Then there's the question of satellites. We're reasonably sure that satellites and technology that depends on them would also be compromised by another Carrington event. Estimates vary widely on how often these events occur. Smaller geomagnetic storms occur relatively frequently but are resolved quickly and only cause minor power outages. The truth is, we genuinely don't know how often these storms of that size occur. Some estimates say these large-scale storms should occur around every 150 years. Since before the dawn of widespread electricity use, we had no way to measure the size of these events, we cannot say with certainty how often they're meant to occur. It could be extremely rare that the Earth is hit by such an event, or it could be a regular occurrence. Until we have more data, we just don't know. Fortunately, we now have the ability to observe and measure sunspots, which gives us a pretty good indication of when and where CMEs are likely to hit. If we can predict these events, we're able to turn off our power systems in preparation to save ourselves the struggle of dealing with long-term damages. We as a society need to be able to handle crises when they come. Are we willing to live without power for a few days to save the progress of our civilization? Can we put aside fear and conflict to protect our world? I hope we won't have to find out anytime soon. But if and when we do, we must be ready. And when the time comes, whether in our lifetimes or our children's lifetimes, we'll have some pretty beautiful night skies. Thanks for watching.